All right, so number 1, and again, it doesn't say to round, which means we're keeping it exact. It says if x is 4 square root 5, and y is 4, and z is 4 square root 6, find the sine of x, the cosine of x, the sine of y, and the cosine of y. So starting with sine of x, opposite x is your 4 root 5. Hypotenuse of the triangle is 4 root 6. And then the 4's cancel, and I get root 5 over root 6. But we can't leave it like that, so we rationalize it. Good.
Times square root of 6 over square root of 6.
And you get root 30 over 6. Good. 30 can break down, but it doesn't repeat. None of the terms repeat, so you're going to leave it like that. That's your sine of x. Then cosine of x is adjacent to x, which is 4, over the hypotenuse, which is 4 root 6. The 4's cancel, and I multiply by root 6 in top and bottom, and I get root 6 over 6. That's the cosine of x. And then the sine of y has what relationship to what we just found? Good. The sine of y is the same as the cosine of x, so you could actually not go through all that work again. Good morning. All right, so it is the same. You could have set it up all over again and then simplified it all over again, but you save yourself some time by knowing that those two things are the same. And the cosine of y is the same as the sine of x. So those would also be the same. Again, you can save yourself some time by knowing that. God bless you. Okay, number 2. Now it says nearest tenth, so we know we're rounding. It says that y is 10.
Capital Y or
Lowercase y. It says angle y is 15. And I want you to find z to the nearest tenth. So in respect to that 15, what's 10, Sophia? Sine would be what side? 10 would be what side? Opposite. And the z that you're looking for? Hypotenuse. So you're using sine. So sine of 15 equals 10 over z. And when the number's in the top, we divide. So z equals 10 divided by the sine of 15. Oh, I'm in the wrong mode. Hold. 38.63, and it says round to the nearest tenth. So 38.63, the 3 drops off, and it's 38.6. Questions on that one? All right, number 3, also a nearest tenth, so we know we're using our calculators. It says if z is 12 and the measure of angle x is 84, find y to the nearest tenth. So in respect to 84, y is what, Mars? In respect to, y is what kind of side in respect to 84? Adjacent, and the 12 would be? Hypotenuse, and which trig function uses adjacent and hypotenuse? Cosine. So the cosine of 84 is y over 12, and now the number's in the bottom, so we multiply. And I get 12 cosine 84. 1.25, this is going to bump it up, so 1.3. Now that seems like a small measure for a side, but if I look at this angle, right, if that's 84 degrees, how small is angle Y? It's aggressive.
Pretty small.
Pretty small, specifically 6 degrees, right? So something that's opposite 6 is going to be a lot smaller than something that's opposite 90, which was that 12. So even though it seems like that's a small side, that makes sense because it would be opposite that small angle, right? Smaller sides opposite the smaller angles. Questions on that one? All right, the last one. A lamppost is 11 feet tall if the angle of elevation through the top of the lamppost to the sun is 49 degrees. Approximately how far is the top of the lamppost from the tip of the shadow? So even though you're talking about elevation of the sun, and it would actually be this angle here as well, we always put it in line with the ground. So from the ground up to whatever it is that the angle of elevation is stopping at is that 49 degrees. and 11 is the side that's given, and we want the hypotenuse. Sophia. Good. Good. Sine of 49 would equal? 11 over x. Numbers in the top, so divide. 11 divided by the sine of 49. 14.6, and it says approximately how far, so you could have left it as 14.6. You could approximate it as 15. That's fine. If it had said like a whole number, then it has to be 15. If it said nearest tenth, it has to be 0.6. But if it's approximate, we're rounding. Questions on that one? All right, this was 18. So it says planes that's funny. Planes the fly, that should be planes that fly, at high speeds and low elevations have radar systems that can determine the range of an obstacle and the angle of elevation to the top of the obstacle. The radar of the plane flying at an altitude of 20,000 feet detects a tower that's 25,000 feet away with an angle of elevation of 1. How many feet must the plane rise to pass over the tower? So if it's already at, what is it? 20,000 feet. Eek. That's the other piece of information it's giving. It wants to know how high it would have to fly to go over the tower. So it's got to cover this vertical distance. It has to fly h higher than where it's at now. So h is opposite. 25,000 feet is your hypotenuse, which would mean sine of 1 degrees equals h over 25,000. And then we multiply 25,000 times the sine of 1. And that's h, which is 436.3. Good. So that's that one, right? Did it say to round?
You have to round it.
Yeah.
Point 3 rounds down.
Okay.
You can't go under.
You can't fly 436.
Oh, it says at least. Okay, I got you. And that's what it wants. It wants you to, you can't bump down. If you bump down, it's not going to clear it. You have to bump up so that it can go over it. That's why it's 437 and not 436. That wording? No. But that's a great standardized test question.
No, that's awful.
The going over it? Oh, we're going to have to bump it up? No, that's what I just said. No. All right, then it says planes cannot come closer than 1,000 feet vertically to any object. At what altitude must the plane fly in order to pass over the tower? So now you want to get it 1,000 feet over it. So I need this to now be 1,000. At what altitude means what's the height here?
20,000.
So how did you get it?
20,000 plus 1,000 plus 437.
20,000, which is this here, plus the 1,000 it needs, plus the 437 that you got from there. So you're adding them all together. I would say this is obviously not a test level question, but this is a great standardized test question. Because it's not just going to, like, no SAT or ACT is just going to give you a triangle and say solve it. It's going to be a word problem format like that.
You know how much
All right, the good and the bad is that 9-6 is pretty much just applying what we did already. So you get the extra practice in it, okay? If you struggled with last night's, then make sure that we pay attention because that's what we're basically reapplying. So we're solving right triangles in the gym. If you are looking for the angle, remember the difference between if you're looking for a side or looking for the angle. If you're looking for the angle, you're using what's called the inverse trig functions or those negative ones. Tan -1, sine -1, and cosine -1 are called inverse trig functions. Inverse tangent is a -1, inverse sine is the -1, and inverse cosine is the -1. So if you ever see it say use the inverse trig functions to find the angle, that's basically what you've been doing this whole time. You just didn't know it was called the inverse. So you would set up your ratio and then you would use the calculator to do the -1s. Example 1 says, draw a diagram showing a person who is 1.5 meters tall, standing 20 meters from the base of a building. Also show that the person sights the top of the building with an angle of elevation of 58 degrees, and then find the height of the building. All right, so you've got a person, right? They are 1.5 meters tall. They are standing 20 meters from the base of a building. And then it says, show that the person sights the top of the building with an angle of elevation of 58 degrees. So that is from their eye level up. So that's your 58 degrees. Then it says find the height of the building. So if I want to find this whole height, what do I do?
X plus 1.5.
Okay, so I could make that x plus 1.5 and you can set up your ratio from there, or you can make it x, set up your ratio, and then add the 1.5 at the end. Okay, that's fine. So the bottom side, this 20 meters is going to be the same as this distance here because those would be parallel lines. And that basically makes a rectangle. Left side would transfer to the right, top to bottom. So I'm going to use this triangle at the top to solve for first. X is opposite the 58, 20 is adjacent to it. Which trig function is that? Good. Tan of 58 would equal x over 20. And then I multiply both sides by 20. And the 20 times the tangent of 58. X is 32.00, so 32, and we're in meters. And then to this, I have to add the person's height, which means I'm adding the 1.5 meters.
So this is the test question.
Sure.
I have a question.
Yep.
So that whole big half of the truck of the building's height is 1.5 meters.
No,
So the
from
guy's 1.5
here,
meters.
from here to here would be 1.5. Then we found this to be 32. So the whole thing is 33.5. All right, this one says when the sun's angle of elevation is 38 degrees, a building casts a shadow of 45 meters. How high is the building? So we start with the building. If I have a building and then I have the sun, which direction would the shadow go?
That way.
It would be here, right? So this has a shadow of 45 meters. Now, even though this angle elevation for the sun would be 38 degrees, like you wouldn't obviously see the sun if you were on the other side, it's going to be the same as this angle because those would be parallel lines, right? Parallel lines cut by a transversal, and those are corresponding angles. So ground up will give you angle elevation of the sun. And it wants to know how high the building is, so that's my x. Opposite the 38 is the x, adjacent is the 45. So we're doing tangent again. X over 45, and then I multiply both sides by 45. This time I don't have to worry about any height because we're saying it's from the ground up. So 35.2 meters. It didn't say it, but it would be specific on your test what to round to. If it said nearest meter, it's 35. If it's nearest tenth, 35.2. Still good? All right, so when you see the instructions that say solve a right triangle, it means find all the unknown side lengths and angle measures, which means that if there's a triangle with 3 parts given to you, you have to give 3 parts to your answer. If it's 2 angles and a side given, then you're giving the other angle and the 2 sides. If it's 1 angle and the 2 sides, you're given 1 side and 2 angles, whatever you're missing. So directions here say solve the right triangle.
Find every side now.
I gotta find angle B, right? Because I have angle A and I have angle C. And I have to find AB and I have to find BC. What's the easiest to find?
Angle B.
Angle B. How do I find angle B?
90 plus 42. Subtract that from 180.
Okay, or just take 90 from 42, right? Because you know the other one's got to be 90,
Yeah.
which is
48.
48. Good. Now, my advice is still stick with the setup using the 42 because if you got 48 wrong, you're going to continue to get everything wrong. So I'm still going to use the 42. I'm going to put an X on the CB and a Y on the AB just so I don't have to write 2 letters every time. But you can totally write the 2 letters. So if I want to solve for X first, it's opposite the 42 and 70 is adjacent to the 42. Good. So tan of 42 would equal x over 70. And then multiply both sides by 70. And I get 63.02, which is going to be 63.0. That's your BC. And then I want to find where I labeled y, which is AB. In respect to the 42, what's the y?
Or it's
Hypotenuse. And I'm going to use the one they originally gave me, the 70, because it's a whole number. I didn't round it, and I know it's right. And that's adjacent. So the cosine of 42 equals adjacent over hypotenuse. And this time we divide the 70 by the cosine of 42. That is 94.19, which is 2. Okay. And then again, if I had extra time, I could use it to check. So that's 94.2. Okay. My 70 squared plus the 63 squared should equal, probably not exact because we rounded, but pretty close to that 94.2 squared. Questions on that one?
0.2. AB.
All right, example 4 says, suppose your school is building a raked stage. The stage will be 30 feet long from front to back with a total rise of 2 feet. A rake or angle of elevation of 5% or less is generally preferred for the safety and comfort of the actors. Is the rake stage you are building within the range suggested? So this time, I'm trying to figure out what that angle is, right? And they drew you the little picture. If I'm trying to look for x and I have 2, which is opposite, and 30, which is hypotenuse, which trig function am I going to use? Sine. So the sine of x equals 2 over 30. You can reduce it, but you don't even need to. You can just do the sine -1 of 2 divided by 30. And I get that angle x equals 3.8 degrees. So is that within the range suggested? Yes, because it had to be less than 5. It said 5 or less than, right? Questions?